is I am no longer going to do homework due dates as the day when we're taking these. Because that is clearly not working. Some of you are not getting the 90% homework grade, you are procrastinating. And again, unfortunately, a lot of those people are not here, so you get to hear about. The day we finish a homework section, the next class period is when that homework is going to be due. For Thursdays, the homework is going to be due on Saturdays, because I'm going to have to stagger those homework assignments. Just people are not working on homework. And like I said, a lot of the people who did not take the exam on Tuesday, did not have 90% homework. So attendance would not even have mattered because they hadn't even finished 90% homework grade. So like I said, we're going to stagger our homework assignments. So we'll finish 3.1 today. We'll start 3.2. I don't know if we'll finish 3.2 or not, but Saturday is when your 3.1 homework is going to be. Once we finish 3.2, a day, 2 days after that is when that homework section will be due, because I'm going to have to do that to force you guys. And once that homework closes, it's closed. So you got to make sure before that homework closes, you get that 90% grade. So we're going to do that and see if I can get some of you, as they say, light a fire under you so we can get you to get that homework completed. So we'll try that for chapter 3, see how it goes. All right, so let's take a look at how the information we studied in section 3.1 can help us solve some application problems in 3.1. So the main criteria here is, remember those characteristics we talked about for a parabola, which was where is a vertex, so how do you find the vertex of a parabola? And depending on how the equation is given to you, is it given to you in the transformation equation form, or is it given to you in the standard form? So based on that, you have to then come up with your vertex. Once we had that information, then a lot of the other information obviously became easy for us to access. So where was your axis of symmetry? What was the maximum value? Where was your function increasing and decreasing? What else did we talk about? The domain and range, of course. So all of these different characteristics that we were talking about, now we're going to take that information and apply it into our application problem. So that's what we're going to next. So you can again see there are some examples we have here in the handout that you guys can look at. This one is talking about, if Chandra wanted to basically create a garden, if she was going to put a fencing to create a garden, I guess wherever, what would give her the maximum area? So how would she go about doing that? This example here is talking about if an archer shoots an arrow straight upward, and then, they're giving you that information. They basically want to know the maximum height that arrow will reach, and when will it basically come back and hit the ground, right? That kind of information. All of these are based on applications of basically what we call as the maximum minimum of a parabola, which is where basically the y coordinate of your vertex falls is going to actually help you come up with these solutions. So we're going to look at these examples here, and you can see this is the archer example. Let's make this some of that will probably not make it completely on the screen. Alrighty, so there, as you can see, they're telling us if an archer shoots an arrow straight upward with an initial velocity of 192 feet per second from a height of 5 feet. So the archer is standing a little elevated from a height of 5 feet. Then its height above the ground in feet at time, which is in t seconds, is given by this function. So you can see that +5 that you see at the end, the constant term, is that 5 feet where the archer is standing above ground level. We know his initial velocity as he shoots the arrow, or she, I guess he or she shoots the arrow, is at 192 feet per second. So that's that middle term. And then can anybody tell me where that -16 is coming from? Why do we have the -16? And then of course t squared to go with that. Because what happens when you throw something up in the air? Comes down. That's actually the constant for gravity. Gravity is what's bringing that arrow back down, right? And this can be done with a ball. We're using an arrow here. So a lot of these kind of examples where we are talking about something being thrown up in the air and coming back to the ground, this is kind of the general format. Now, if any of you need to take calculus, you will actually be revisiting this, but done a little bit differently because they're going to talk about derivatives. At that point here, we're just doing this in a very simple form. So as same questions that were in the handout, what is the maximum height reached by the arrow, and how long does it take for the arrow to reach the ground? So let's see how we can break this up. So just to give you a little bit of a visual, imagine this is the ground level. So this is the 5 feet elevation that he's standing at, or she, I guess, and then they shoot the arrow. Now, the projectile of anything, and if you guys remember that, what was that game? I think it was called Angry Birds, wasn't it? Where you were throwing pigs at birds, or birds were throwing pigs, or something like that. They are going to make that parabolic shape. The same thing happens if you're tossing a baseball, right? It makes that little parabolic shape. I guess the same thing with football. So it's going to reach its maximum height, and then it's going to start falling down. So we are asking you, what is that maximum height reached by the arrow? So technically, we are asking you to find the vertex of this parabola, and then that y coordinate for the vertex is going to be our maximum height. And we know that because look at how the equation is defined to us. The t is actually acting as your x coordinate, the independent variable, and the height is acting as your y coordinate, the dependent variable. So based on time, we will be able to calculate the height of the arrow. So 0 seconds will be when the arrow is shot, right? Because that's the beginning. And then if you did 1 second, it will tell you how far the arrow went. If you did 2 seconds, it will tell you again how far the arrow went. So by the time we get to the vertex, we will know how many seconds it takes for the arrow to reach its maximum height. And after that, it's going to start making its descent. So can you tell me how we're going to calculate the vertex for part A? Very good, yeah. So let's see if we can do that. It's going to be the second form of the equation here, because we are given the equation in the standard form. So you calculate your x coordinate by this formula, -b/2a, and then put it back into the function to find the y value. Okay, so let's do that guy here. The x coordinate is going to be the formula -b/2a. And then for the y, we will put it back. X here, so that would be -2a. What is our b and a values in this equation? And those of you who are online, of course, you guys can share your answer, but send it directly to me, not to everyone. What your A and B values are going to be for the x coordinate. So what's our B? Very nice. It's gonna be the middle term. This is B. And what's the A value here? Very nice. Yes, take the sign with the number. Brenda, very nice. Alrighty, so the A value is of course coming from that square term and it's going to be with the sign. You gotta take the negative with the number. So negative 16 for A, which will of course then end up giving us negative 192 divided by negative, what is that, 42? Two negatives will cancel each other out. So you will actually end up giving a positive number, which we should, because remember T represents time and that's after the arrow has been shot, how much time has passed. So we cannot really go into negative time. So we should end up with a positive number here. And what is that? 6. Alrighty, so it means it's taken the arrow to reach its maximum height 6 seconds. However, they're not asking us for the time when it reaches maximum height. They want to know the height itself. So this is just part of the way. Then we come back and put that answer we just came up with back into the function. So you do age of 6, which will end up giving us negative 16 at t squared. So that will become 6 squared plus 192 times t. So again, our t is 6, and then you add the plus 5 of t. Now, again, we've kind of talked about this before, but that negative 16 is on the outside, right? He's not part of where the square is happening. So the negative sign will stay in this case. So you will end up with negative 16 as it is. Of course, 6 times 6 will give you 36. Whatever 192 times 6. So go ahead and simplify all of that. If we did 36 times 16, still the negative sign stays, right? So just multiply those guys together, which is coming out to be 576. Hopefully this guy will be larger than that, so we can get a positive answer, because again, height should be positive. So 192 times 6 is going to be 1152 plus the 5, which will give us a total value. So this will be in feet. And what is our height going to be, the maximum height the arrow reaches? Very nice. Yes, 581 feet for the maximum height. And this is exactly what they want the answer for part A to be. Plug this guy in, 581. So far, so good. Before we move on to part B, did anyone have questions on this part A? Anyone who was unable to come up with 6 and the 581 values? Those of you who are on Zoom, Brenda, Ezekiel, did you guys have any question on part A? That's okay. That's the constant for gravity, because, and the reason it's negative is because it's going to fall down. So because that direction is, going downwards, that's the negative direction. That's where the negative 16 comes. Looks like some people do not have any questions, so let's move on to part B. I am actually going to clear this one out. Okay, so now they're asking us basically when it reaches its maximum height and when it's going to come hit the ground. So they want to know how long it's going to take when the arrow reaches the ground. So you're finding t, which means we have to know what h is. What is the height going to be when the arrow reaches the ground? Very nice. Yes, it is going to be 0. So when you solve part B, you're going to use h as 0. Does anybody know what this calculation is called? When you set one variable to 0 and you find the other one? Very nice. You are actually finding your x-intercept here, or t-intercept in this case, since we're calling that first variable t. So in this case, we would be using the same, but you're going to set your h of t as 0. So you will have 0 equals negative 16 t squared plus 192t plus 5. And we need to then, factor the expression and set it equal to 0 and find our t values. Now, since this is a second degree polynomial, a quadratic formula, you are going to come up with 2 answers for t. And then, once you come up with those, you will kind of have to make the decision, which answer makes sense, which does not, which one do we use, which one do we discard. Now, what would you use to solve a quadratic equation here? Which method? And remember, we've talked about 4 different methods: factoring, square root property, completing the square, and the quadratic formula. What would we use to solve this guy? Quadratic formula, I probably imagine that's going to work the best. I'm really not sure if we're going to get a good factoring out of this. So let's do quadratic formula. So again, you need to identify your A, B, and C values. We already know A is going to be negative 16, B is 192, and of course that means C is going to be 5. For your quadratic formula, remember that is negative B plus or minus square root of B squared minus 4AC, and then the whole thing divided by 2. So again, this is actually an example I do believe shows up on the exam. So it may not be a bad idea to practice this and make sure you have all the formulas that you need to solve this. So let's see, our negative B is 192 plus or minus underneath the square root. Again, you'll end up with 192 squared minus 4 times A is negative 16. C was 5. And then the entire thing divided by 2 times A, which will be 2 times. Let's clean this up. Of course, negative 192 in the front, plus or minus, clean up what's inside the radical, inside the square root. So 192 squared. Going to be obviously a large number, 36,864. Minus, actually, when you look at that second part, and let's see if I can get one. Then you will see we have negative 4 and negative 16, and of course we're multiplying all of that. So go ahead and combine your signs together at this point. So I would say negative times negative will end up becoming positive. So you can actually go ahead and get your positive sign put in there and then just multiply the 4, 16, and the 5. Now, if there were 3 negative signs, then 2 would become a positive, 1 would still stay back. So those will be, just depending on the types of examples you end up with. You'll get a practice with that, but we're doing negative and negative as positive, and then 4 times 16 times 5, which will come out to be 320. And then the denominator, you'll end up with negative 4. Okay, what is 220 plus 3, 6, 8, 6? We will have to see if he is a perfect square number or not. The round you now have 37,100. Okay, so let's take a look. 37, if I take the square root on that. 37,184 minus 4. You're not gonna get a perfect square number here because it's giving you a decimal answer, and I can show you that. Thirty-seven, 184, and you put the square root in that. You will see it gives you a decimal answer, so that tells you it's not a perfect square number. You're not gonna get, like 4 gives us 2 or 16 gives us 4. It's not one of those values. So for now, I'm actually gonna leave it as a square because I don't want to write that big ugly decimal. Here, we will need to separate this, so you have 192 plus and the square root of 37,184 divided by negative 32, or we have negative 192, and this time we have the minus sign, square root of 37,184 divided by negative 32. So we're separating that plus or minus sign that we've kept together. So each one of these is going to give us a t value, right? Because that's going to tell us the time when the arrow hit the ground. So we need to figure out what those timings are going to be. And then for this one, I'm actually going to go to decimals. And I'm just going to pick their scientific calculator. And again, I apologize, guys. I know I have everything written. So let's do a fraction. We're going to do negative 192 plus the square root of 37,184, and then divide by negative 32, and you can see we're getting the answer on the right hand side, which is coming out to be negative 0.025 something. I'm going to negative 0.0. Or let's see what the second t value will give us, and that's going to come from the minus sign. I'm actually just going to change because I've already typed everything. I'm just going to come back to where I have this type and just change that plus sign to a minus sign, so that way I don't have to go back and do the whole calculation again. And you will see this guy ends up giving us 12.02 something. So this one has 12.02. I think it's the same decimal. This is a Everybody okay of how I came up with those two numbers? Yeah. So let's actually go back to that screen here so we can see this better. Alrighty, so which answer makes sense? The negative 0.0259 or the 12.0259 as when the arrow reached the ground? The 12, because you again cannot have a negative height, negative time, because here you're basically talking about going back in time, which is not possible practically, at least not until now. So obviously, if in 6 seconds it reached the maximum height, then it makes sense the number has to be larger than 6 when it comes back and hits the ground. So 12 seconds makes more sense, and then you can see what kind of rounding they want us to do. Which is telling us 2 decimal places, so that will be 12 point, let's see, 2 decimal places, so what are we looking at? Did you say? 0.3, because you have 2, 5, so the 5 will make the 2 go up, which will become 0.03 when you do your round. Does anybody have question on part B of this guy? How to calculate that time when the arrow is going. When does he go to them if you have a question on that? So this question is a little bit different than the one in the handout, but this should give you an idea. I'll just solve this example. Okay. And I apologize that this is very small, but hopefully you guys can somewhat read it. A rectangular playground is to be fenced off and divided in two by another fence parallel to one side of the playground. 600 feet of fencing is used. Find the dimensions of the playground that maximize. So again, they're asking you to get the largest area possible. Maximize the total enclosed area. Hint, write a quadratic function for the area and find the vertex. So you can see we were talking about the maximum height with the arrow question. Here we're talking about maximum area. So we're still using those same concepts, but in this case, you are talking about maximum area, which means we have to talk about area formulas to try and come up with a quadratic equation. So again, let's see if we can get a visual aid to help us with this. So we are talking about a rectangular playground. And it's going to be fenced off. So of course, we're putting a fence all around the 4 sides and divided in 2 by another fence parallel to one of the sides. Now you can place that fence however you want. I'm just going to place it vertically right in the middle. So we're dividing that playground into 2. If you wanted to do horizontally, you can. It should work out in both ways. The equation might look a little bit different. So I think we've got the visual. Divided in 2 by another fence parallel to one side of the playground. Got that. We have a total of 600 feet of fence. And based on this one value, we have to come up with what is the maximum area we can have for the playground. So, of course, the idea is you're going to put that fence around all 4 sides of that rectangular playground, but you're also going to be using that same fence to divide that playground into half. What formula do we use when we're talking about putting up a fence? Is it the area formula? You have to use the perimeter formula to begin with because the fence is going to be put on the perimeter, right? And the easiest way to remember of when to use perimeter or area is fencing, like in this case, goes on the edges, right? So that's going to be the perimeter formula. If you were laying sod or grass, if you were painting a wall, where you're covering the entire surface, that's area, right? So in this case, since we're talking about fencing, we're going to be talking about perimeter. Now, normally for a rectangle, your perimeter formula is twice the length plus twice the width, but we will need to modify that in this case because we do have the length. So we can think of this as being the length. Same thing here, this guy is being the length, so we do have our two lengths. And, but then this side and this side here is going to be your width. And since we are dividing the playground in the middle, we are actually going to end up with three widths in this case. Now, if you guys did a horizontal break, then that would mean you would end up with three lengths and two widths. So just depending on how you're breaking it up. With mine, it's going to be three widths, which means we will actually need to change this last part once. There we go. That will actually end up becoming three. So two lengths plus three widths, and that should equal how much fencing you have. So that will be 600 equals twice the length plus three times the width. Are you with me so far? Anybody who has a question at this point? Brenda, Ezekiel, questions at this point? No? All right, now we are talking about the maximum area. So obviously we need to use the area formula. So again, area for a rectangle is length times width. Now you cannot have two unknown values when you're working with an equation. You should have only one variable, right? Just all x's or all, y's or whatever. In this case, it should either be all in terms of length or all in terms of width. So that's actually where that perimeter formula is actually going to come into play. Either get L by itself or get W by itself. So you're rewriting that perimeter formula by trying to get just the length measurement or just the width measurement. I'm trying to think if it would be easier. Okay. We start by dividing 3W on both sides. We'll end up with 600 minus 3W, which means you still have the 2L left over on the right-hand side. These guys will cancel out. And then to get L by itself, we would divide everything. And I apologize if that's too low for some of you to see. Which would end up giving us, just cleaning this guy up, 600 divided by 2 would be 300. Minus that 3/2 W will stay as it is. And then the 2 and 2 cancel out, so just leaving us with the F. You have 300 minus 3/2 W equals L. So when you come back to your area formula, since we have this guy over here in terms of L, you are going to make that substitution over here. So the L times W for the area, the L gets replaced with what we just came up with. So that's the 300 minus the 3/2. And this is where your quadratic formula comes from, guys, because you will now distribute this W inside the parentheses. So you'll multiply it with both the terms inside the parentheses, which will end up giving us 300 times W minus 3/2, and then W times W will give you the terms. Our area is going to be 300 W minus 3/2 W squared. And you can see this is where we only have one variable now because everything is in the terms of W. We're not having to worry about length separately and width separately. If you had rewritten this perimeter formula here for W, if you had gotten W on one side and L on the other, then my area formula would all be different. So it just depends on how you rewrite a perimeter with which letter, and the other one ends up becoming more dominant. Okay, so we are talking about maximizing the area, which means again, we have our quadratic formula. Let's find its vertex. Now, if it helps you to rewrite this in the standard form, that would be putting the negative 3/2 W square in the front and the positive 300 W in the back. So it looks like our standard form. And since we're using W as our independent variable here, we will again do negative 0/2 here. Put that back in the equation divide. All right, negative B over 2A. So what is our B and what is our A value here? So what's the B? Very nice, the middle term, yeah. So 300, very good, and then the A value. And what do we do with the sign? Very nice, yes, do not lose that negative sign. So the B value is the 300, the negative 3/2 is the A value. So negative 3/2. Let's talk about this. Negative 300 divided by -3. Because you have 2 on the top, 2 on the bottom, they will cancel each other out, leaving you with, which works out really well, because the 2 negatives will again cancel each other out, giving us, and we are talking about the width, which is a measurement, so it should be, or a distance, if you want to think about it that way, so it should be a positive number again. So the 2 negatives cancel out, 3 goes into 3 once, so this actually ends up becoming 100 for the value of okay. Now, let's find out what the larger dimension would be, which would actually be our L value. So we'll put it back into, actually, I was using the area. No, we're trying to find the length. So we will actually come back to this guy, the perimeter formula, the 300 minus 3/2 formula. So to find the length, 300 minus 3/2 W. We do have a width of 100. Obviously, since we are talking about the length, this should be a number larger than 100. What do you think it will come out to be? Length? Salvatore, what did you have? You don't have? Okay. Well, what happens with the 3/2 times 100? When we simplify that, what does that give us? Yeah. Because if you cancel out, and you can do this by hand or plug it into a calculator, 2 goes into 150 times, because you're basically taking the half of 100. 3 times 5 is 15, so that becomes 150, and that's basically 150. Because you don't think about this, you have a total of 600 feet of fencing, 300 of that is going to be used for your width, because you're putting 100 here, 100 here, and 100 here, so that's 300. You're only left with 300 feet of fencing after that, but you're dividing it between the two lengths, so that will come out to be 150 each. So that's what you end up getting over here, plus you. So our smaller dimension is going to be the width, which was the 100 feet, and our larger dimension is going to be, of course, the length, which is at 100 feet. Okay, let's plug this in. Sorry, 100 for the smaller dimension. And then the larger dimension would be 50. So you will notice here, they're not asking you for the area itself. They want to know what the dimensions will be, which gives you the maximum area. So that's your length and width. Okay, questions on this example here? Yeah.
What would happen if we, instead of dividing it, it was less than you don't, or
You would still get the same dimensions. You would just be looking at a very different way of laying out. Because you cannot really have multiple different dimensions, right? To maximize the area. The only difference would be the area that I have, like, let's say on that left-hand side of my rectangle would get distributed lengthwise, but the area is not going to change, which is what we would call as the maximum area. They would just end up, your numbers may become smaller, which I don't think would happen again, because you still have to do 100 times 150 to get the maximum area. So yeah, I don't think your dimensions would change. Because the space is not changing, it's just how you're dividing the center half, which is the difference. Are you dividing it vertically or horizontally? But the 4 dimensions on the outside should not change. Okay, very good. Any other questions on how to break this down? Okay, so the reason I use these 2 examples in class is because these 2, I don't know if both of them show up or one of them shows up, but these examples do show up in your test. So that's the reason why I like to go over this, because I want to make sure you guys are comfortable. So again, remember your due date for homework for 3.1 will be, I guess, 12, 13, 14, Saturday the 14th. And I know some of you have already gotten started on your homework, so hopefully you just have to finish the last part of it and get it completed. Yeah, we'll keep it. All right, guys, so we've talked about the characteristics of a polynomial now. Now we are getting into those higher degree polynomials. So you know what happens if you get to the 3rd, 4th, 5th, 10th power of a polynomial, and what would we do to solve those kinds of higher degree polynomials? So this is where we're bringing in some theory. So we're starting out with the remainder theorem. There we go. So basically when we're talking about, finding the solutions or finding the zeros or finding the x-intercepts, we're actually talking about the same thing. We're just saying what x values will satisfy your equation so that you can get, basically a 0 value for your y coordinate. So x-intercepts, finding the 0 of a polynomial, finding the solution of a polynomial are used interchangeably. They're basically talking about the same concept here. So we're basically saying, if you have a polynomial, y equals p of x, a value of x that will satisfy that polynomial where your y value is 0, that value is what we call as the 0 of the polynomial, the x-intercept, the solution of the polynomial. So that's what we're trying to figure out here. Now they're talking about just a simple example here, p of x equals x squared minus 9. So when you try to solve this, your zeros come out to be +3 and -3, because when we plug that in, you will see your y value comes out to be 0 in that case. When we put this on a graph, you will notice that at those values of +3 and -3 for the x value, they are exactly where you would expect your x-intercept to be. So that's exactly what we're going to be doing even when we get into higher degree polynomials over here. That's what we're going for. So we're saying for polynomials of degree 2 or less, the zeros can be found by solving your quadratic or linear equations. Our goal is to find all the zeros of the polynomial function when possible. So your remainder theorem basically is evaluating a polynomial to basically if you were doing a division of polynomials. So here we're specifically talking about if you have a remainder left over, if there is a remainder, if R is the remainder, when a polynomial P of X is divided by this term of X minus C, the idea is if you take this number C, put it back into your polynomial, the answer you get should be the same as that remainder. So we're not talking about finding the zero here in the remainder theorem. We're basically saying if you take some number C, divide your polynomial by that, with the expression X minus C, you will end up with the remainder, which would be the same thing. If you plug that number C back into your polynomial, the answer you get should be the same as your remainder. So let's take a look at this little guy. Let's clear this up. Right, so just plug him in, let's see what happens. So if I did P of 1, and that's going to be using this polynomial here, that would be 1 squared, because we have x squared, minus 7 times x, which would be 7 times 1, plus 9. So as you can see, when we simplify this, we're not going to get 0 as an answer. We're going to get 1 squared is 1, minus 7 times 1 is 7, plus 9, which will end up giving us, what is that? -6 plus 9, which is 15. Now, if we're to put this in play, with the theorem that we just talked about here, if I divided my x squared minus 7x plus 9 with the expression x minus 1, because remember that 1 is your C value. Once you go through the whole math, you should have a remainder of 3 left behind when you do the long division. So that's kind of what they're talking about in terms of the remainder theorem. If you take your polynomial divided by that x minus 1, the remainder that you get is the same answer when you plugged in that 1 into your polynomial and the answer you get. So I've actually shown you that example. So if we did the long division, which is what you're seeing on the left-hand side, your textbook calls it the ordinary division. So just get familiar with that term because you will see examples in section 3.2 where they ask you to solve by ordinary division. So what's happening here is you can see this is what I had written down as well. X minus 1 is dividing into x squared minus 7x plus 9. So you start out, you have 1x over here, you have x squared over here. So the idea is I'm one guy short, so that's why we bring in another x, so that when I multiply this, I get x times x, which will be x squared. Then I multiply this x with the -1, which is where dividing x minus 1 into x squared minus 7x plus. So as I was saying, since you have x squared over here, you are gonna have to bring another x at the top. So you're multiplying the dividend. Yeah, divisor. Oh my God, I'm getting lost. No, I think the x squared minus 7x plus 9 is the dividend. The x minus 1 is the divisor. Multiply both of these terms with that x we just brought up at the top. So when you do x times x, you will get x squared. When we do -1 times x, you will actually end up with negative x. Anytime, and this is with numbers, this is with polynomials, anytime you are doing long division, once you have your multiplication done, you always subtract. And that is why in the example I have on the second page, those signs are different, because that means this guy ends up becoming negative. You know, so that negative sign transfers over here, and then the negative and negative will end up making this guy positive. So however you want to write that, I'm going to leave that up to you because you have to figure out what works. So I'm basically telling myself this guy's going to become negative, and this guy is going to become positive once I do my little subtraction, which is going to work really well for us because now I have a positive x squared and I have a negative x squared. So they'll end up canceling each other out. You have a negative 7x being added to a positive 1x, so negative 7 plus 1 will end up giving us negative 6x, and then just bring down that plus sign. So over here, okay. I already have the x term as part of my x minus 1. What I'm missing is the negative 6 over here. So that is what you're going to do, is just bring in negative. I'm just going to bring the negative 6 because that's all I'm missing. When I multiply my negative 6 with x, I will get negative 6x here. But I multiply -1 with negative 6, again, negative times negative becomes positive, and we end up with positive 6 here. And then again, you have to subtract that expression. So when I do the little subtraction, the two negatives here will again end up making this guy positive, and negative times positive will actually make this into a negative. So again, those signs will change, which will then end up giving us negative 6x here, positive 6x here, so they cancel out. And then you're just combining what we're left behind with, which is a positive 9 minus 6, and you can see the end up with 3, which is exactly the same answer we got when we did this third calculation. You can see a lot of those numbers are the same as we were doing by the long division or by substitution. It's the one on the left.
Can we just, are there some problems that?
Yeah, some problems are set up where they require you to do, and it may be 1 or 2 problems, there's not many, because you do start using synthetic division there. Because you know, and I'll show you that here in a minute, but synthetic division does actually work a lot quicker than long division. There is one example, and that will come when we start talking about asymptotes a little bit later. But there is one example where synthetic division does not work, so we will have to fall back on synthetic for that. But for most other ones, if they just say division, you're welcome to use synthetic. Yeah. Okay. So any questions on just this process right now, the long division part? Yes. Yes. Like I said, I was telling Valeria, there are some questions which will want you to do the long division. Yeah. I mean, this question is just because we're introducing the concept to you, but you will see other examples of long division. Any other questions, guys? Okay, so let's make sure we save this. Filling out. Okay, so again, that's the same calculation that we just did, but a bit more cleaned up over here. Now for synthetic division, which is what you're seeing on the right-hand side, you should notice that we're taking the coefficients from your polynomial expression. So of course you've got, this is the 1x squared, so that's the 1. The middle term was -7, so that's where the -7 is coming from, and then your constant term was 9, so that's where the 9 is coming from. You are dividing by x minus 1. So normally, if they tell you divide by x minus 1 for synthetic division, calculate that and you will see you're actually dividing by positive. If they give you something like p of 1, then of course you're dividing by 1, then you don't have to do it. But if they give it to you as this expression, like a binomial term, and they're saying divide by, x minus c format, then solve that with 0 and get the answer for what x should be. So what happens in synthetic division is basically that first number comes down as it is. You're not doing any kind of calculation. Just bring that first number down as it is. Then you start multiplying. So 1 times 1 is 1. That's where this number comes from. And then you just add or subtract, whatever the signs will be. So you can see -7 plus 1 will end up giving us -6. Then you take the -6 and again you multiply it with it, which will still give you -6. And then when you add, you'll get the answer. So that final number on the right-hand side is your remainder. And we've seen that with 2 calculations now. 3 is our remainder. And the first, whatever is to the left of that number becomes part of your quotient. The other thing is, we started out with a second-degree polynomial. This was an x squared expression. Your quotient is always going to be 1 degree less than what your polynomial is. So if this is x squared, that means this guy is going to be an x. If your polynomial was x to the third, your quotient will be an x squared. So the quotient is always 1 degree less than the polynomial you were defining. And I think I mentioned that. Right. All right, let's take a look at an example on how to do this. Right, so this is an example of ordinary division. They're asking us to find the quotient number. So we're dividing by w minus 3. And our original expression is -4 w cubed plus 6w squared. You will notice there is no w term, right? We have w to the third, w to the second. So we actually need to make space for the missing term. And then put the negative line. And this will be true for long division, ordinary division, or for synthetic. You always make room for the term that's missing. Otherwise, your calculation will get jumbled on top of each other. So -4w cubed plus 6w squared. Your single w term was missing, so we're making space for it by putting 0w, or you can leave it as a blank space. It doesn't matter, but keep space for it and then bring down the negative. I'm not seeing you. So let's see, your leading term here has -4. We need to bring that in. You have w to the third power, but our divisor has only 1 w, which means we need 2 of them. Because you have to have the same matching power. So if I take 1 w from here, 2 from here, the 2 and plus 1 will give me the 3 power. All right, so then multiply. I'm taking w times -4w squared, so that will end up giving us -4w cubed. You also multiply the -3 with the -4w squared. So negative and negative will become positive. 4 times 3, which is 12. So negative and negative, positive. 4 times 3 is 12, and then the w squared. And then remember, we subtract. The subtraction means your signs will change. Which will make this guy into a positive 4w cubed. And that will become a negative 12w squared. So change those signs. Which tells me, our negative 4w cubed and positive 4w cubed will cancel each other out. And we will be left behind with, let's see, I've got a positive 6w squared and a negative 12w squared. So positive 6 minus 12 will give you negative 6. Of course, the w squared will stay. I still need to bring down that missing term and then bring down the. So your first term cancels out because that's how you set up these problems. First term cancels out, and then the other terms, based on what you had, will clean up or bring down which were not affected. So now I have a negative 6. You will put a negative 6 up here. You have w squared, but only one w in the divisor, so of course we need to bring in the w. So you will end up with negative 6w multiplied with w, so w times w of course gives you w squared. Negative 3 multiplied with negative 6w, so again negative times negative will become positive. 6 times 3 is 18, and that will be 18w. And that's it. Again, you will be subtracting that. So change your signs inside the parentheses. This guy will again end up becoming positive. This guy was already positive, so he ends up becoming negative. Which again means negative 6w squared and positive 6w squared cancel each other out, leaving us behind with, let's see. Now you had a 0w, right? Because that was the missing term. So obviously nothing will be affected with the negative 18w. That will stay basically as this comes down. And then bring down your, that looks like an 8. And then bring down the. So negative 18w minus 9. And we should only have one more step to go at this point. Because now since you have negative 18w, we already have a w here, so we just need a negative 18 at the top, which will end up giving us negative 18 times w is negative 18w. And then negative 3 times negative 18, so negative times negative is positive, and 1 is 18 times 3. 54. All right, so let's take a look at him. So you would again need to subtract this. And that means we will end up with, let's see, this guy will become a positive number. This guy will become a negative number. Negative 18w, positive 18w will again cancel each other out. And at this point, you're left with negative 9 minus 54. Alrighty, thank you. So this is our remainder. This is the remainder, and this term at the top is your question. We will have a quotient first, so that's negative 4w squared. Negative 6w, what is it, negative 18? Check him. Remainder was negative 62. Check that. Now, if you wanted to check and see if your calculation was correct, and this was, of course, before you were plugging in your answer, remember what they told us in the little remainder theorem. You can take your little polynomial here and substitute the W with 3, and you should get negative 63 as your answer. So if you did negative 4, so to the third power plus 6W squared would be 3 squared minus 9, you should get negative 63 as a leftover answer. So that's negative 4, 127 plus 6 times 9 minus 9, which will give us plus 27 so 54 minus 7. That's 8 stuff. Okay. Again, one last time, any questions on this example? Okay, so as you can see, this was one of those ordinary division questions. Let's see. Yeah. All right, so this one is asking us to use synthetic division, but again, same thing, they want the quotient and the remainder. So what would this diagram? So since you have that you're dividing by a plus 1/2, set that equal to 0, so you know that you're actually dividing by negative 1/2 in the synthetic. Now, if this was ordinary division, you would leave that a plus 1/2, but since you're doing synthetic, we do need to find the balance. So you will be doing negative 1/2 as your divisor. And then let's see what these guys will look like here. So your leading term is 2. The first number is 2. Then you have negative 7. And we don't have missing terms, so make sure about that because you have a to the third, a to the second, a term, and then the constant term. So you have all 4 of them, there's nothing missing. Negative 7, then you have a plus 4, and constant term is also plus. So set those up. Remember what I told you, bring that first term down as it is. You do not do anything to that first term. Then you start multiplying. So you're multiplying 2 with negative 1/2. If it helps, you can write that out as a fraction. You have 2 on the top, 2 on the bottom. Basically ends up becoming negative 1 is what we're left behind with. That negative 1 goes up here, guys. Then you add or subtract those two numbers, depending on the signs. So since I have negative 7 minus 1, of course, I end up adding those. Keeping the negative sign, it ends up becoming negative 8. Now you're going to multiply negative 8 back with that negative 1/2. So negative 8 multiplied with negative 1/2. Again, if it helps, you can write it as over 1. 2 negatives will become positive. 2 will actually go into 8 4 times. So you will end up with 4 times 1, which will give you a positive 4. Again, that positive 4 goes right over here. And since both my numbers are positive, again, we end up adding them. So 4 plus 4 is 8. And 8 goes down. Same thing, multiply the 8 with the negative 1/2. And again, you can write that as over 1. In this case, you have only one negative sign, so the negative will stay. And 2 will again go into 8 4 times, so 4 times negative 1 will give you. That negative 4 will go here. 0, as you remember. So he is the remainder. He is the quotient. Now, as I was telling you before, your quotient is always going to be 1 degree less than your polynomial. So the quotient will actually come out to be 2a squared, so 1 degree less, minus 8a plus 8. That's our quotient. So 2a squared minus 8a plus 8, that should. You will be talking about this later on, but anytime you get a zero remainder, guys, that actually means that -1/2 that we were dividing by is actually one of the zeros or one of the solution to this polynomial. So -1/2 is one of those, x-intercepts or a solution or a zero, whatever you wanna call it, because that will be a test we will be doing later on. So anytime you divide your polynomial by a number and you get a zero remainder, that's actually a solution to come up for that one. All right, let's plug these guys in. So we have 2a squared. 2a squared minus 8a plus 8 as the quotient. Very nice. And the remainder was 0. So synthetic division. Questions? Yeah. Depends on the situation, because like I was telling Valeria, again, there's gonna be one example where synthetic's not good. You will have to fall back on both. And it doesn't tell you in the instructions, but that will be something you will have to make a decision. And we'll do that as an example, so you'll know which one. But a lot of times it does depend on the polynomial to see which one works a little bit better than the other. All right, very nice. Anybody else? Okay. So this is kind of what I was talking about, but before we get into this example, let's come back here. Okay, so yeah, this is kind of where they're talking about how the ordinary division or the long division is not always an efficient way of evaluating your polynomials. Synthetic division can evaluate polynomials using fewer arithmetic operations, even than what you use in the substitution method. But again, as I was just telling Salvatore here, there are some examples where you have no option. You cannot use the synthetic division method and you have to go back to do it. Okay. What I want you guys to do is, as practice, I want you to work on this one and let's see what you get for your quotient and remainder on this guy. So using synthetic division, divide this expression, you're dividing, they're asking you to find P of 3, which means you're dividing by 3. And then make sure you get your terms here for the expressions of the polynomial. And then let's see what you come up with. And again, those of you on Zoom, just directly to me, once you solve this, share your quotient and remainder. So that we can see that everybody's comfortable solving this. Let me ask you this, are we missing a term or a real term? Yeah, missing a term. Yeah, all right, so make sure you're creating space for that missing. Yeah. So you will see that those numbers in the bottom. No, you're not substituting, you're using this method. Kind of like the example we just did. Hi, math. So you're dividing by three, so three will go on the outside, like I have. And then create a little, some kind of divisions. With a sheet. Alright, then here you can put the coefficient. So set up. So what's the coefficient for this? Nope, so that's the expression. Because the coefficient is the number that you use. So then there's. What about this? Now what term is this? Okay, so go ahead with this one. And then we go to this one. 1 plus sign, you're not putting any process of things, just the coefficient. So you don't need this. Is that the confusion? So put in space for them to see. No, because it's missing, right? That's what it is. And then go to last. Now in this guy, since he has the negative, we want to put the negative. But not as a minus sign, as a negative sign, because it should come zero. It's not zero minus, it's the non-zero. Very good. So now you're going to perform that synthetic division. We want the first one as it is. So same thing like the one here, like the coefficient. Also, let's put in the number one. Very good, that's your missing part. So you brought the one. No, I didn't. No, it's just whatever the signs of the systems are, they're positive, you just end up at. And then go back and multiply the 4 with that 3 and go. So that is one with this. So what's the. If you did 36 minus 10, that would be. Now it's considered 10, it's 9, which means you take one number back, right? You put one number back. So 1 degree less than that, so chill out the extras that we have too much. It should be X. But since that was third, this will be second. So just change this to X's and we're good to go. And you're not putting X's left, you have to be putting the coefficient. So technically, there's no number which means it's actually. Yeah. Yeah, put it on there. Ladies, have just be as possible until the last. I think it's okay if you put it, it's not incorrect. All right. Here we go. Am I gonna have to teach you guys how to add? Alrighty, let's take a look here. I have Brenda's answer. Yeah, something's happening. All right, let's take a look at this guy then. You have coefficient of 1 from the x to the third power. You have a coefficient of 1 from x to the second power. You have a missing term here. So that becomes the 0. And then, of course, the -9 goes at the end. You do want to leave good spaces between these so your numbers don't get jumbled in and you have enough space to work. So once you have this setup written down, remember that first number just comes down as it is. And a lot of you were getting confused by including 3 there instead of 1. So that may just take a little bit of practice, to get used to these numbers. But whatever is that leading coefficient comes down as is. And then you start multiplying. So we're multiplying 3 times 1, which will give us 3. So that 3 again goes above the line, right? Because you're combining it with those coefficients from your polynomial. So we add 3 plus 1. And guys, let the signs tell you here. If there was a negative here, then, we would have subtracted. If both were negative, then you combine them, keep the negative sign. So all of that will be the numbers that tell you. So right now I'm seeing a +1 and a +3, right? So we end up adding them together. So 3 plus 1 is 4. Once you get that 4, we go back and multiply him with that 3 on the outside. So 4 times 3 is 12. And this is why we need that blank space or that 0, because otherwise, if you didn't keep this 0 over here, you would be tempted to put that 12 on this side, which would be incorrect. And that's why you have to make room for that missing one, because if you didn't have this little gap here, the 12 would have gone under the wrong number. And that's why it's very important to make sure you include those spaces or zeros for the missing terms. Of course, 0 added with 12 will give us 12. Go back and multiply the 12 with the -3, so that is 36. And then now you can see we have a -9, a +36. So when you combine them, you end up subtracting, which gives you 27. So remember, this guy is the remainder, and this guy is the quotient. So your quotient, 1 degree smaller than your polynomial. So since we had a 3rd degree, this will end up becoming x squared plus 4x plus 12 Right? So plus 12. And then your remainder. Now, as I was telling you, if you wanted to check, just for the checking part is where I would do what some of you were asking me is, doing the P3 and then substituting that into your polynomial. Plus, what would that be? 3 squared minus 9, so that's 27 plus 9 minus 9, which the plus 9 minus 9 cancel each other out. So just by doing substitution, you will get the remainder, but it's not going to tell you what the quotient is going to be. So to get the quotient, you won't need to do the long division or synthetic division to find the quotient. But in a way to check, it's not bad to do the substitution, because if you know you got the right remainder, then your calculation for the quotient is also right. So that's a good way to just check your work in a way. Question on, I guess, synthetic division at this point. All right, so let's stop here because the factor theorem is going to take us a little bit of time. So we'll pick up with the factor theorem and the example. So guys, 3.1 homework will close on Saturday at midnight. I would also recommend once you're done with 3.4, maybe practice a little bit with synthetic division, so that when you guys come back to class on Tuesday, you're feeling more confident with it, because it will help. Because going forward, we're going to be using synthetic division. Okay. All right, everyone, have a wonderful weekend. Enjoy, and I will see you guys on Tuesday. Brenda, Ezekiel, did you guys have any questions before you left? You good? Okay, alrighty, if no questions, I'll see you guys on Tuesday. Take care, guys. Have a good weekend. Thank you, you too. Yes. So. Yes.